All right, so another tool we have is integration using partial fractions. So I've got written on the side integration using partial fractions, and I've given you something to think about. So I've got 7/12 written as 1/3 plus 1/4. So these two fractions, if we get a common denominator, right, they're going to be, this one will be times 4, this will be 4/12 plus this one times 3 will be 3/12. I picked something really easy. So you can see that 7/12 equals 4/12 plus 3/12. This is another way to write it. So the point is that we're going to take things that have algebra in them and we're going to separate them. Our goal is to find the factors of the denominator so that we can then, our goal is to find the A and B that makes our numerators work. Okay, so let's see what I mean. Let's actually do one. Example 1. Example 1 has us finding an integral for 1 over x squared minus 5x plus 6 dx. In the ones we've seen before, if the denominator had its derivative in the top, it would be of the form, this would be u, and u prime would be in the top, and we could integrate that easily. This is not the case here because the derivative of the denominator would be 2x minus 5, and I don't see that in the problem anywhere. So what I want to do is I want to rewrite this so that I have the common denominator separated. So I'm going to integrate, and if I do that, so obviously this is going to be x minus 2, x minus 3. I don't know how to separate that, what the top is to add up to 1. In other words, let me just do it and see if that helps at all. I'm going to say I don't know the numerator for the x minus 2 plus I don't know the numerator for the x minus 3. So what I'm doing, I'm making new fractions that have these two denominators, and I don't know what the numerators are, but I do know that a plus b has to equal 1 because that's my 1 here. So I am rewriting this of a form that later I'm going to be able to integrate easily. So let me go back to the numerical example. If you were given 1/3 plus 1/4, you could easily add that up and get 7/12. But what if you were given 7/12 and you needed to write it out in two separate fractions? And so that's my goal here, and bear with me through this example, and then we'll do some more, and then maybe by doing some problems, what we're doing will make more sense. So my goal is to make these two separate fractions look like this one. And if I'm going to add fractions that have different denominators, then I'm going to have to multiply this first fraction by x minus 3 over x minus 3, and this one by x minus 2 over x minus 2. And you're thinking, that's a lot of work. We already had the problem, but I couldn't work this one. So this is how I'm going to work it out. And what that gives me is the integral of a times x minus 3 plus b times x minus 2 all over x minus 2, x minus 3. So now I have the partial fractions happening, and I can now make this numerator equal to this numerator, like this. 1 equals ax minus 3a plus bx minus 2b. How does that help us? Well, I need for the right-hand side to be equal 1. I need for the x values to equal 0x, because I don't have any x's on this side. And I need for negative 3a and negative 2b, the numerical values, just numbers, no variables, numbers to equal 1. So I'm going to do this. I'm going to say that the x values, and I'm going to use the coefficients, a plus b equals 0. So these three things are put together. And then the numbers are put together. So negative 3a minus 2b equals 1. So these are the x values, and these are the constants. And now I have a system of equations that Algebra 2 I can solve. And how would I do that? I need to have a common thing. I'm going to multiply this whole top one by 2. 2, 2, and this would still be 0. These cancel. I now have negative 3a plus 2a is negative a equals 1. A equals negative 1. And if a equals negative 1, then b equals negative 1. B must equal positive 1. It's opposite. Does that work? So if I plug it in right here, I would say negative 2 plus 2 times 1 equals 0. Okay, so that works. Now, how does that help me at all? Well, if I go back to this problem, and I fill in my a's and my b's, right? So I'm going to put, instead of a here, I'm going to put negative 1 and x minus 2 plus b is 1 over x minus 3. And I still have a dx. I left that off up here. Sorry. It should have all been dx'd. Anyway, now we can integrate them separately very easily, because the integration, if this is u and its derivative is 1, this is just the natural log function. It's not, it has chain rule, but it's not very interesting because this derivative is 1. So the derivative, the antiderivative here is going to be negative natural log absolute value x minus 2 plus the natural log of x minus 3. Again, this antiderivative is the natural log, and this doesn't have a derivative, so I don't need anything special here, plus c, and I have my final answer. You could combine these if you wanted to. You could put them into one. This is an answer, so this is fine. But if you want to combine it into one natural log, log rules say that you would put the one that's negative in the denominator. Natural log, we would put x minus 3 in the top because this whole one is positive. This represents a negative exponent. Negative exponents go on the bottom. And it's a 2, sorry. 2 plus c. I have two ways to write the same answer. So again, why did I do this? Well, this original problem, the derivative wasn't found anywhere. So we had to use partial fractions, two separated smaller fractions that when split up are easy to take the antiderivative of. They're easy to integrate. And to do that, I don't know what the numerators are supposed to be, so I have to go on the side and figure them out. Okay, and what we're going to do with figuring them out is we're going to set up a system of equations that has us figuring out the coefficients of the x values and the coefficients of the constants, and then with the system of equations we can easily solve for a and b. Let's do another. Okay, example 2. Integrate negative 2x minus 7 over x squared minus 3x minus 4. So while you're writing that down, x squared minus 3x minus 4, its derivative, like we would try use substitution here, and if we use the denominator for u, its derivative is not up here. That would be 2x minus 3, not minus 7. So u substitution doesn't work. Long division is not the choice because the numerator is not bigger than the denominator. So instead, we want to try our new trick, which is partial fractions. We want to find the denominators. So I've got x minus 4 and x plus 1. That would be another way to write x squared minus 3x minus 4. And what I want to do is find the two fractions where a over x minus 4 plus b over x plus 1 will give us this negative 2x minus 7. So we've separated them into two smaller fractions with smaller denominators. I need to make it actually work, right? So I need to say, well, this only is equivalent if this fraction is multiplied by x plus 1 over x plus 1, and b over x plus 1 is multiplied by x minus 4 over x minus 4. And then I can say they're equal. So what ends up happening is I have this, a times x plus 1 plus b times x minus 4 is supposed to be equivalent to negative 2x minus 7. There are multiple ways to approach doing this. I like to set it up like a system of equations. I like to see, okay, ax plus a, that's the distributed, plus bx minus 4b equals negative 2x minus 7. And here I'm going to say, well, these three things in circles go together because they're all the x values. And then a and negative 4b, including the negative, and negative 7, those go together, and that's how I'm going to set up my system of equations. So I'm going to look at coefficients only here. So I'm going to say, in the pink, a plus b equals negative 2. So I'm stripping away the x's. I'm trying to find the coefficients. So I don't keep the x. I'm just looking to solve for the coefficients. And then I need these coefficients in blue circles to go with each other. So I need a minus 4b equals negative 7. And now I have a system that I can solve. I can change all the signs, right, so that the a's will cancel. And that gives me 5b equals 7 minus 2, or 5b equals 1. So now I know that this fraction is really 1 over x plus 1. I've figured out this fraction. Now I need to solve for a. I can go right here. A plus 1 equals negative 2. A equals negative 3. Now I have the second fraction, negative 3 over x minus 4. I have rearranged this complicated fraction into two very simple fractions. So partial fractions, these are the partial fractions that made up the original, and these are easy to integrate. Again, I can move this negative to the outside. I have a simple logarithmic. Actually, I can do this. I can say this is negative 3 and then 1 over x minus 4 plus the integral dx plus 1 over x plus 1 dx. This makes it negative 3 natural log of the denominator plus natural log absolute value of the denominator plus c. And we can combine these into one answer if we like. This one will go, actually, because of this 3, I'm not going to. That changes things. I'm going to leave it completely separate. I could combine it, but I'd have a cube somewhere, and that does get kind of sketchy. So up here, all the coefficients were 1. That was easy to do. Down here, this 3 makes it more likely that I'm going to leave the answer written out completely. So what's our goal here? Our goal is to find an equivalent fraction with a smaller degree denominator. And the reason for that is that the integral of 1 over something simple like x minus 3, that integrates to the natural log of absolute value of x minus 3 plus c. And so I don't need the original problem to have the derivative up here anymore. This is very simple to integrate. So I'm looking for a simpler way to integrate. Okay, so that's basically the gist. There's some challenging problems in the homework, but I tried to make notes so you can follow. And obviously go to CalChat if you have more questions. The gist of this whole section is for us to find the A and the B, those partial fractions, so that we can integrate with natural log. So in that sense, it's kind of similar to the section where we did long division to find natural log. This is another way for us to do that. All right, let me know if you have questions.